Okay, so today I want to talk about how I like to make a site plan and how to input a site plan. And we're going to do it in two ways. The first way will be looking at a PDF and how we input the information from a PDF to manually draw this. And the second would be, and the most preferable way, is if we get a CAD file, what I do and how I make a site plan using a CAD file. So the first thing we can look at is the CAD file. Let's see. So I got the the PDF file. So here's the PDF file, and you could do a couple of things with the PDF. In fact, I'm going to show the PDF in two different ways as well. The first will be what I would call the old school way. Essentially manually entering it in. Then I'm going to show a second way after that. So, in fact, let's just kind of keep it right here. So the first thing I want to do, we can talk about how do we take this information and enter it in. And we do that using bearing inputs. And in AutoCAD, this section right here is how you would enter this in. So you essentially start drawing a line, and then you're going to say at however big, for example, 150 feet, where here this one you can see is 173.64. Then space and caret, and then the direction. And here this says north 55 degrees, 21 minutes, 32 seconds west. So here we'll look and we see this says south 21 degrees, 0 minutes, 0 seconds west. So this is the information we need, and this is how we're going to enter it in. So to follow, I'm going to pull this off screen, but you can see the information here. And we're just going to start drawing a line. It doesn't really matter. So I hit L for line and I start drawing, and it's just drawing a line. I'm going to come down here, and in my bar I'm going to type in at 173.64 feet. Actually there is no space, sorry about that. So we're going to try it again, at 173.64 feet, and then caret, which is the shift, and it's the one above the comma, so shift comma gives you our caret. And we want to say south 21 degrees, 0 minutes, 0 seconds west. So you can see I typed all that in right there, and then we'll hit enter, and that gave us the line. Then you could figure out directionality. I'm not overly worried about it, but for example, drawing it this way and adding in the parameters that we're talking about. So the line we drew is essentially went from right here to here. So it's giving north directly up. So I'm just going to draw this generic arrow just for reference, and we'll get into that in a second. So now I want to draw this line, and I'm going to draw it separate, and we're going to connect them. And you can kind of trace around, but it's usually a little bit more hassle than it's worth. So this one we want 66.21 feet, and then that's the direction. So start a line anywhere, it doesn't really matter. And we're going to say at 66.21 feet, caret south 58 degrees, 01 minutes, 33 seconds east. And enter. So now that's that line, and we can move it from here to here. And now we're going to do the third line. We're going to do this one right here. And so we'll draw a line and say at 161.02 feet, caret south 21 degrees, 0 minutes, 0 seconds west, enter, and we'll connect that to there. Now the last one, actually I take that back, there's two more. You can see there's a C1 right here and an L1. So L1 just means another straight leg, but it's a small leg, so they gave us the information here. And then C1 is a curve, and they gave us the information here. We're going to do the L1 first. So start drawing another line and say at 9.08 feet, caret north, 75 degrees, 9 minutes, 44 seconds west. So there's our little guy there. Plop him in. Now, there are much more, I'll call it sophisticated ways of putting in the curb information, especially with delta and whatnot, but really the easiest way is I'm going to start with the radius, which is 225 feet. So I'm going to draw a circle with a radius of 225 feet. So that's the radius. Now we know there's a length of 56.13 feet. So I'm going to draw a line at 56.13 feet. And actually the easier way of doing it, sorry, I'm actually going to draw another circle with a radius of 56.13 feet. And what that does, this distance right here will be our 56.13 feet. So I can trim this by here, and this should be our arc. That will be this arc right here. And now we'll just rotate it, which is what the delta and a couple of other things do. But again, this is just the easiest way to do it. You can see we got really close to closing. It didn't quite close, which is why I don't like using this method. This is the old school way. But for this purpose, we're just going to close it and call it a day. Now, that's why I like using CAD files to make them much more accurate and not have to worry about that information. I'm going to go ahead and put everything on the 0 layer. Now, what I like to do, so this is our road. So this is what we're going to be dealing with, which, if you remember, I'm just going to draw this little diagram just for ease of communication. Whenever we draw a site plan, we either want the front of the house facing that way or facing that way. So that means this will be our front of our house. So I'm going to go ahead and move this guy. I'm just going to place him right here. It doesn't really matter. This is just going to be my north arrow reference. And I'm going to put him on def points. And I like adding it and making it a color of 171, which is this purpley color, which is not a color we use for anything else. So I know it's def points and a lot easier to see. So now I'm going to rotate this whole thing, and I'm going to rotate it by this point right here, and then say reference, and give a base point, and then grab up here, and then I'm going to turn on my ortho and come out here like this. So now what I did was I rotated the site plan away from being orientated with true north up to an orientation that I can work with, but I still have my north arrow direction, and that'll be important in a second. I'm going to get rid of this because I don't need it right now. Then lastly, I like making this a block. So the way I like to make a block is just I draw a line, and if you copy and paste, which is the quickest and easiest way to make a block, whatever the bottom left value is, meaning whatever, you can have a shape that looks like this, doesn't really matter. If you were to project over from here to here, this point right here will be the insertion point. So whatever the bottom left of anything is in its absolute kind of relative to its own absolute lines is where the insertion point will go. So if I just draw a simple line like this, the bottom left will always give me an insertion point right there. So I'm going to do Control X, Control Shift V creates a block. And so I can just drop it right there. So now this is a block. And if I double click it, you can see it's now bring me to my block definition. I'm going to actually highlight the name, copy it. So Control C, cancel. And then I'm going to go REN for rename. And old name, I'm just going to paste that in right there. And then I'm going to rename it to whatever I want it to be. Most times I just put the address in, but for this example, I'm just going to call it Survey 1, just because I'm going to do a couple versions of this. And I'm going to say OK. So now I haven't done anything. It's still just a block, but if I click on it, you can see it says Survey 1. I'm going to do RFE for reference edit, reference this, and now I can highlight these two and add to working set. And now I can erase this. While I'm here, we can add in our setbacks. I don't know what the setbacks are for this project offhand. I'm just going to kind of make these up. So I'm going to say O for offset, 120 for 120 inches or 10 feet. And I'm going to say, let's go 10-foot setbacks. I think it's actually 5 in this project, but or 7.5, whatever it is. Then I'm say offset, let's go 25 feet for a front setback. Actually, this is just the curve, so I can't just offset. I kind of need this attached. So I have a custom command made that allows me to combine polylines or lines into polylines very quickly. So if I type in PJ and then enter, I can select these two lines, and that's now instantly a polyline. So this will go offset 25 feet, and now I can offset that whole thing 25 feet. And let's say offset 30 feet for the rear. Let's just kind of close it out. I'm going to make a polyline and go intersection, 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 and then find, that's the end point. So that's essentially this end point right here, offset down. Type A for arc, intersection, and then L to go back to line. See, I'm back in line mode, and then C for close. And now I can erase these offsets, and that gives me a polyline for my setback. And I can turn these into a combined polyline, which is my property line, so PJ again. So now that is a polyline, and that's a polyline. I'm going to do one more thing. I'm going to go File, Open, and I can help set this up if you need help. Those of you who are in my office and work for me. But I have a lot of helper files, so I'm going to go to my AutoCAD and my site parts. If you don't do this, I highly recommend creating these database of parts. It just really speeds up workflows. Here I'm going to get into a lot of typical notes that I use over and over, as well as layers. I can do all kinds of layer matching or select layers. They're all pre-built into our files, but sometimes I like just having quick and easy copy and paste. I'm just going to grab these. These are my site property lines and my setback lines, and we'll talk about these in just a second. So I'm going to copy all those, come back to here, and we're going to paste these, and I'm going to match U to U. Actually, I'm going to leave this on the 0 layer, and I'll show you why in a second. But this is a block I have, and it just gives these round nodes to show where property line intersections occur. So I'm going to copy those all around. And if you look at the PDF, it's essentially what they're doing right here. So it just makes it very clear where one line starts and the next line begins. So here are typical, these are our setback line. Actually, I don't know why that should be our dash line. Our green is our typical bi-layer setback. I use some of these other ones for different things. Usually I use just more for visual reference. They don't print any different. My magenta is for easements. My blue is for like a pool setback. And if I happen to get a second floor setback, I'll usually use the yellow. So this way when I'm drafting, I know the intentionality behind the setback. So I'm just gonna match properties from here to here. And then we'll erase these, and I can do SR for save reference. And I actually want to do a copy and paste of this one more time, because I was copying it and pasting it into the block, and that's not really what I wanted. I want to do outside the block. So now we'll match properties, and since this is on the 0 layer, it puts that properly there. So now we have this north arrow, and if we're going to start making a page layout, the first thing I want to do, and I usually do this, this is my page layout, and these are old school drafting way of doing elevations where you can actually rotate around the plan. We used to do elevations that way, but we don't really do that much anymore, so I'm just going to clip those out. So I'm outlining my page, offsetting 4 inches, and then doing X clip, clipping my page, saying new, and then select polygon, select that one, and then, so now they're clipped out. And actually I should have waited, because to do a site plan, these sheets, I don't tend to work in paper space. I tend to like to work better in model space, and so I create my page layouts in model space. This is set up to print at 1/4 inch, so I actually just need to scale this up by 2. And so you can see this is my 1/4 inch paper, which makes this one my 1/8 inch paper because it's scaled up by 2. I'll just scale this one back down by half just so I have a 1/4 inch one there as well. So now I can move this property. You can see I can just place it wherever. You know, I'd get a little bit more specific in a little bit, but I just want to show that we can now put it on there. And lastly, to put a north arrow in, if we type in NA for north arrow, it brings in our block, and then we just place it where we need to. But now you can see our north arrow comes in pointing up. So the way we do this is I will snap to here and go to my north arrow guide, and I'm going to rotate this north arrow, and then use R for reference after rotate, give myself a base point, reference point, and then a rotation point. So now our north arrow is pointing the right way, but our box is not. But we have this built, so if you grab this node and pull up, that re-rotates the box back up. So now we have our north arrow in line with what is actually going on. And I tend to leave this. It's on def point, so it'll never print. So that's how I tend to leave it. You know, you can move it out of the way if you really wanted to, or erase it altogether. But I like just having it as a reference for where true north actually is. So that's how I build a site plan. We'll get maybe a touch more into detail on the last one, because we'll maybe use that one moving forward. So the next way, again, continuing to use the PDF, is you can import the PDF. So off screen right now, I am opening the project, and I'm just going to grab the site plan, the PDF, and I'm going to plop it onto my CAD file, and it's asking me what page number. I'm going to hit right click for page 1. Actually, I don't want page 1. What page do I want? This is page 4. So that's important. I'm going to again drop it in here, and I'm going to type in 4, enter, because that's the page I want. And then I'm just going to put it down. Doesn't really matter. We're going to find the scale and make sure that we are scaled up properly. This is 1 to 30, which I probably, let's try it again. I think, was it if I hit 360? I forget offhand. I have a conversion chart somewhere. So page 4, insertion point, let's go 360. That might have actually done it. We can test it by, if we know this is 66.21 feet, I'm gonna type in DS for distance, specify the first point, and I can, even though this is a PDF, it's a a vector PDF. So you see, these are actually lines I can snap to. So I'm going to snap to that point and then snap to that point, and see, this gave me a distance of 68.5 7/8. So it's close, it's not quite right. So we are going to rescale this by rotating, and then I'm going to say reference, and again give base point, second point, and then I'm going to give a uneven axis. I don't care about the general rotation right now. All I wanted was just to give this line to be parallel with what my typical axes are. So now I'm going to give myself a reference line. So I'm doing a polyline. Starting here, coming up, doesn't really matter. Again, this is all just reference stuff. Now I'm going to type 66.21 feet, enter, and then down. So you see we're off just by that much, but the easy way to fix that now is I'm going to type scale, select this PDF, and then it's asking for a base point. So I'll give here a base point. Then again, I'm going to say reference. And then I'm going to start from the far left and go all the way far right. So I want this point here. So we will make sure we are snapping to the end point. Now if I reference it back and go perpendicular to this yellow line, it'll now scale this to be perfect. So if I do a dimension, you can see 66.2.5, which is roughly 66.21. I think we can change this to read as decimal. Where is it? It doesn't really matter, but it's always like just to show, what am I looking for? There we go, dim units, architectural, we'll go decimal. Actually, not decimal. Which one do we want? Engineering, because decimal is giving me inches. Close enough, I'm not worried about it. Either way, that's what it is, but we can also check by, I'm going to do another dimension, and we'll do an aligned dimension, and we'll snap from here all the way down to here. And this is giving us a dimension of 173'8", which this is 173.64 feet. Do the quick conversion on the calculator. 173.64 feet equals 173.64 equals 173.7 and 11/16. So this is, let's look at our rounding factor. This is going down to an eighth. If I change the dimension round off, it's still coming right at an eighth. So we're off by, what is that, 5/16 of an inch over this whole thing. So again, we were never going to be hyper accurate doing this way, because we're as accurate as whatever this is, whatever their round off is. You know, so it's as close as we can get. But the point being is, with the PDF here, I'm going to rotate this one more time because I want to match the previous one we did. So I want to find this base point right here. So rotating, gave it that reference base point, a snap to here, and then we'll go flat this way. Now we should be able to go PL for polyline, and I'm going to start right here, and should just be able to trace around this, snapping to these endpoints. And this is a straight line coming to here. And then we will go arc and CL for close. And that is a perfect outline. There is a 12-foot utility easement, so we'll add that in just for the fun of it. So now if I move this up over here, and we do the same thing, I'm going to put this on my 0 layer. So we'll go 0, and I'll draw this line, Control X, Control Shift V. I'm going to double click, copy, orient to rename this, paste the old name, and then this one we'll just call Survey 2, just for the heck of it, RFE to reference edit, add. Now this is already a polyline, so just to make my life easier, I'm just going to copy one down. Now I'm going to copy it down 100 feet so I can explode it, and then I know I need to poly join these two guys again because we're going to offset 25 feet for that setback. And we also saw that we have a 12-foot utility easement, so we'll throw that in there. Offset 30 feet, offset 10 feet. And then if I really wanted to, I can just, I'm going to explode this, and then we'll fill it. So this is a different way. Last time I drew these as a polyline, but this time I'm just going to fill it, these edges. I'm going to extend using EX to extend, PJ, and I'm a polyline join that. And now I can move the setbacks up 100 feet and erase this. And what that allowed me to do is we can match that. And I think I said I used my magenta for easements. And we'll erase this, and let's copy these nodes. Because it's grayed out, that means it's actually not part of the block. So we'll select it and say add to working set. And now it's part of it. So we'll copy and move node, 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 and node. And then SR to save. And then we can match to put this whole thing back on. So there we go. So that's the other way. And in reality, let's see how close these came out. They might be different, they might not be. So this one, these are pretty identical. You can see slightly off, just so slightly off by between the two. So that's where, you know, accuracy is always a concern. Oh, we didn't do our little north arrow reference, but you know, we could have while we were in there, and that's fine. Now, to show the obvious and the best way is we can utilize the CAD file that was sent to us by the surveyor, which again is always going to be the best. It's about as accurate as you're ever going to get. So I'm going to layer isolate, and I'm just going to copy this over. Let's copy it over 300 units. Turn everything back on. I can grab, because I personally like keeping a very clean survey, but we're going to keep the things that are of high interest for us, which this line would be. So we're going to copy this over 300, as well as all of our right-of-ways and those sorts of things. So let's see here, layer isolate, LI for isolate. And this is like our street curb. So we'll copy that over, because I don't want to use their layering system. So we're going to have to change the layering system. which is, kind of why we're going to take this over just the pieces we want, and we will match layers to what we want. So there's our right of way, center of road, all that good sort of stuff. And in reality, I don't care about their layers, so I'm going to put everything on the 0 layer anyway. And I'm going to create my own, I don't want to bring their block in. So I'm just going to create my own little faux north arrow, if you will. We will put this onto 0. And we will copy that and we will paste over here. Now you will see the scale is going to be completely different because there's a tiny little guy, but it's because they are drawing in, it's not metric, but they're drawing in decimal. So all we have to do is scale this by 12 and you will be back up to the same scale that we're dealing with. So we'll pull this down. So you can already see we already have more information. Did I forget the... I did not bring this guy over. 300. Let's just extend this and put that over there. Whoa. I don't think I had I copied, but I didn't have ortho on, so I'm putting ortho back on so I know we're exactly where we're supposed to be. Let me just make sure. Yeah, everything else is good. And we will match, grab, copy, and paste. I'm going to rotate, reference, space, reference, rotate, and scale all this by 12. Get rid of this one. And just like before, copy this down, 100, PJ, let's go offset 25 feet. And now we're going to explode, offset 10, and 10, and 30. And now we'll fill it. And close up. PJ for that. And then I'm going to PJ all of this, which is just, again, remember my polyline join. I'll move this up 100 feet. Get rid of you. So now we have our curb, we have our center line of road, we have our easements and our water. Just project this down just to be clean. Throw this onto def points and make color 171. And just to be consistent, we will do this as well. Double click, copy, REN for rename, and then we can call this survey 03. Okay, and then we will reference edit, bring everything in. We can erase this little guy. And now I'm just going to move these guys over so we can match properties. The green for that setback. We will do that for that guy. Even though I said this was pool, which I normally use as a pool, this is a water line. So I just kind of like using water setbacks, if you will. So this is going to be an important one because this is the edge of water, which often sometimes the pool or rear setbacks can come off of edge of water, so it's just important. So we'll keep that there again just for reference for if and when we need it. And then going back to my site parts, I have my site road, and my site, center of road. So I'm going to copy these just so I can match layers. So we will match this to here, and we will match this to here. So now I know these are my curbs, these are my center lines, this is my property line, utility easement, my setbacks, and then my water line. So we are all good. I'm just going to drop this somewhere down there. SR to save, and then we can match properties. Oh, I forgot to add my nodes in, so RFE to add nodes. So we'll copy, add to working set, and then move, snap, copy. So just go around to each one of them, SR to save. And now this would be our final site, and this is probably going to be our most accurate, and we can see how well we did. So if we place this one over top, and again, all looking pretty good. It's about, it's about as accurate. Let's see if I highlight this. This one right here is the surveyor's one. So you can see we're close. I mean, very, very barely off, so that's not a bad thing. So you can see you can get pretty close doing it this way, but you'll never beat the absolute, you're as accurate as a surveyor is, and that's really what we're looking for. So that's the beginning of how we do it. The other things I'll eventually do is inside of this block, I like to grab, again, these nodes, and I would have, I have this, this is like a dynamic block. I'll just copy this and we'll add one or two in. I'm going to paste it in place. It's already set, you can see, to my site notes. And I have this little node right here that I can grab and move. And I'm just going to copy this around to each of these. Don't worry about the positioning just yet. We'll do that. And then for the curve, I'll grab this, because this has all the curve information that could be had, even though they only gave us a little bit, but so we'll just use what we need. So this little block here, I have it so you see this node I can actually rotate, but I'm going to start here. I like it on the outside, so here I can say, if the center's on the top or the bottom. So I like that one better. This one is perfect. This one's perfect. This one I want to flip to the outside, and then we can rotate. So now it's nice and clean right along that. And this one I think I'm going to flip as well, so that I can go, because you always want to read left to right. So since this is kind of slanting from top left to bottom right, that reads better versus, if I were to rotate this 180, it feels upside down to me. So I'll leave it like that. So here we'll just double check our data. So we would just put this in. So this will be off screen, but I'm just going to copy this information. We can start here. So now if I double click on it, it opens this. So again, just following. So south 58 degrees, 1 minute, 33 seconds east. And then it is 66.21 feet in length. So now you can see this matches this. And we'll just kind of keep going around. This one would be south 21 degrees, 0, 0, west, already there, and 161.02. And I'm actually going to copy this because I think this side is similar. So we'll paste, which it is south 21, 0, 0, west, and then this changes to 173.64. Go okay. And then Here's our line data. We're just going to update this. So again, double click, and our line data is north 75, 09, 44 west with a distance of 9.08. Say OK. Now our curve data is only giving us length, radius, and delta, so that's all we're going to use. So here's our delta, so I'm going to follow that, which is 14, 17, 32. Our radius was 225, and our length was 56, 13. Sometimes you'll see the tangent, sometimes you'll see the chord, and sometimes you'll see the bearing. Wasn't on this one, so I'm just going to leave it off. So I'll put this, somewhere here, and I'll just point it to it like that. So then here, again, I'll reference edit this block. So now you can see I'm inside the block, and I'm going to grab all of this data and add to my working set. And this is why I like making this a block, and I'm just going to grab a couple more things really quick. Let's go utility easement. Let's go side setback, rear setback, and I'm going to use this one. The only difference between is I have this as like rear setback as a single line, rear setback as a double line. Actually, the rear setback, I can do that. The side, I like the double because it's usually pretty small, and the front we'll do it this way as well. So we will copy these. I just like doing it this way because it already has the data I need. I like not having to redo things. So I'm just going to place this using NEA for near. So it connected those two as a dot, and then we're going to rotate and then give a reference to this point, come out anywhere, go here, and then I'm going to do PER for perpendicular, and so it rotated it just enough to make it tangent to this angle. So now you can see it gives me a perfect 25-foot setback. We'll do the same with the utility easement, and right now I'm just kind of putting them in a place I don't think they'll be in the way. If I need to move these later on, we'll do that, but I'm just kind of giving a starting point. PER, and then extend, whoops, and there's that, and then side setback we know is 90 degrees, so I'm just going to rotate it 90 degrees. I'll start off hitting it in the middle and hitting in the middle, and then rear setback, we'll come here, plop it, rotate, reference, perpendicular, and then extend, and then we'll SR to save. So this is now a block, and I like doing it as a block versus drafting this stuff as loose geometry, I'll call it. This way, if I need to move the site, whatever, this stuff is all linked and relative to each other. This stuff should never be pulled apart. So that's why I like working this way. We can move this guy out of the way and move this guy in, and this is now, setting up our site plan. If the road is really long and gets in the way, you can also, I'll just draw this rectangle for reference, and you can always do XC for X clip, click the block, and then you can trace the rectangle and then delete it. And so now you can see we just clipped it, it's X clipped. So that's the other nice thing about making it a block, is I can control kind of what is seen, even if I keep everything. So it's just a nice way of doing it. From there, we'd probably fill in some more information, get more this other stuff, but this is the core of how we would put all this together. and start the site plan. From there, we would start blocking out and making sure the house fits. The next time video, I'm going to show you how I would convert this into a SketchUp model so that we have the same information and can start building a 3D model based upon the same information.